This section is called a summary of factoring, which I guess gives me two thoughts. One is that it's nice finally to see all the different types of factoring we've done over the last couple of sections finally come together and you figure out when to use what. The other thing is at the beginning it's going to be a little bit tough because like when we did difference of squares, you did 10 problems and they were all difference of squares because that's what the section title said. Then when you did difference in sums of cubes, they were all sum and differences of cubes because it was in that section. Well, now it's not in any section. It's in the section that says factor completely. So how do you know which one to use? So the first note on the top says that you should make sure that you factor your polynomial completely, meaning that none of the factors can be factored any further. The first step, and we saw this a couple of times in the last video, is to check for a common factor. If there's a common factor, it could be a number, it could be a variable. Pull that common factor out first. Then look at the number of terms. If it's got two terms, try sum and difference of cubes, try difference of squares. If it's got three terms, it could be a perfect square trinomial, especially if the ends have perfect squares, or just general factoring, guess and check, AC method, that type of thing. If it's got four terms, try factoring by grouping. Group the first two, group the second two. You may even have to switch terms around a little bit in order to get it to that point where it can be factored by grouping. And then the third one says, check to see if any of the factors can be factored further. So like if you have an x squared minus 4 as one of your factors, you can continue factoring that as a difference of squares. It says repeat until they're all prime. If you go to do one of these factoring problems and you can't factor it at all, then we just say that that question, the factors are already prime, there's nothing I can do. I can't factor it. It's like saying, give me all the factors of 7. Well, 7 is a prime number. 1 and 7 are the only factors of 7. This I just stole out of the textbook. It's got a nice summary of factoring. If you like it, it's in your book in section 6.5. And again, factor out the greatest common factor. Look, they gave you what happens if it's a binomial, difference of squares, difference of cubes, sum of cubes. If it's a polynomial of 3 terms, then they gave you perfect square trinomials, what they're calling FOIL and reverse, grouping, etc. Make sure that the polynomial is completely factored. So I'm not going to do every one of these. I think I have like 15 problems up here. But I'm going to pick and choose a few of my favorites, and we'll take a look at how these are done. So look at the first one, 3x to the 4th minus 3. First thing I'm going to do is I'm going to pull out my common factor. So my common factor is a 3. When I do that, I'm left with x to the 4th minus 1. All right, this looks to me like a difference of squares. X to the 4th is a perfect square, 1 is a perfect square. So the square root of x to the 4th is x squared. So it looks like an x squared minus 1, x squared plus 1. Try multiplying it back together. X squared times x squared is x to the 4th, plus x squared minus x squared goes away. Negative 1 times 1 is negative 1. X squared plus 1 can't be factored any further. That's already done. But you notice this thing over here is again a difference of squares. So that thing has to be factored again, and the x squared plus 1 just comes down for the ride. X squared minus 1 again is a difference of squares. Square root of x squared is x. Square root of 1 is 1. One of them gets a plus. One of them gets a minus. FOIL the insides here, you get x squared. Minus x plus x goes away. 1 times negative 1, negative 1. So what's my answer? My answer is all of this. So realize that if that x squared minus 1 is not a prime factor, right, I can still factor it further, then do it. Don't try to factor that x squared plus 1. There's no two numbers that have different signs that add up to 0 and multiply to be positive 1. Doesn't work. All right, look at number 3. Number 3 is x squared plus 62x plus 63. So suppose we start making ourselves a list of factors of 63, right? This should be a relatively easy problem, at least it looks so, because there's a 1 before that x squared. And so I'm just looking for factors of 63 that add up to 62. So 1 and 63, 3 and 21. It's not an even number, so none of the even factors will work. 7 will work. 7 times 9. What after that? Will 9 work? Yeah, well, we already got 9 and 7. So I think these are all the factors there are of 63. Which one of these adds up to 62? Well, that adds up to 64. That adds up to 24. And that adds up to 16. So none of them add up to 62. So we say this one is prime. because I can't find anything that works. I can't find anything that matches. The product is 63, but none of the sums are coming out to be 62. All right, on this one, let's take a look at 5 and 6. All right, so 5 first. This has 4 terms, so I'm going to think of grouping. I'm going to group the first 2. I'm going to group the second 2. So for number 5, when I look at this first piece here, an x to the 4th and an x to the 3rd, what do they have in common? They have an x to the 3rd in common. So let's take x to the 4th divided by x to the 3rd, I get x. Take 4x to the 3rd divided by x to the 3rd, and I get 4. Now, the second term has a big factor in it. Now, suppose I look at that and I go on, I can see they got 25s. 125 divided by 25 is 5, so I get 5x. 500 divided by 25 is 20. But look, a 5 and a 20 still both have a common factor in there. So now let's pull out another 5. 25 times 5 is 125. Divide these by 5 and I get x plus 4. So if at first you pull out the 25 and you're like, yeah, I think that's the best that I can do, and you still have common factors, you got to pull that common factor out too. All right, so these both have x plus 4, so I'll pull out the x plus 4. And what am I left with? Over here, I'm left with an x cubed. If I pull an x plus 4 out of the second term, I'm left with 125. But wait, this thing here is still factorable. It's a sum of cubes. The square root of x, cube root of x to the 3rd is x. The cube root of 125 is 5, because 5 times 5 times 5 gives me back 125. So I'm going to keep the x plus 4. And then when I go to factor the x cubed plus 125, it's a sum of cubes. So remember, this is the one that goes short one, long one. How does the sum of cubes go? A and a b, a squared, ab, b squared. We started with a plus, right? X squared plus 125, so it goes same sign as I started with, opposite sign, last one's always positive. There's my answer. All right, so this was a twofer. First thing I had to do is I factored by grouping. Factoring by grouping gave me the first part of my answer, but then I realized that the second part also factors, that x to the 3rd plus 125 is a sum of cubes, and so I can factor that further. So I wasn't done until I got down to the bottom, and I can't factor it anymore. All right, for number 6, let's look at that 16, the 24, and the 9. Any common factors between 16, 24, and 9? I don't see any. The 24 and the 9 both have 3s. The 16 and the 24s both have 8s and 4s and 2s, but nothing seems to overlap. So now let's look at the variables. I have at least one x and one y in each of those terms. So I'm going to divide through by xy, pull it on the outside. So pull out my xy, and I'm left with 16x squared, because the y's go away. 24, if an x and a y drop out of each one, I get just an xy. And then the last one is 9y squared. All right, when I look at this one, I got a 16x squared and a 9y squared on the outside. That looks to me like a perfect square trinomial. So let's try it. A 4x and a 3y. What sign? Well, this says the two signs are the same because they multiply to be a positive 9. This says they both have to be negative. Okay, FOIL it out and see if I'm right. 4 times 4, so I get a 16 and an x squared. A minus 12xy, another minus 12xy, so minus 24xy, and plus 9y squared. Clean it up a little bit. I got an xy. I got a 4x minus 3y squared. All right, on this one, let's tackle number 9. Let's see if anything interesting happens with number 9. First of all, I see big numbers, like really big numbers, like 112s, 96s, and 160s. Well, if I look at the 160, because I mean, I could start with 2s, right, and start taking 2s out of everything, but I think that might take too long to take all those 2s out one at a time, and there might be too many. So instead, let's see if I can think something bigger. 16 and 10 multiply to be 160. So I wonder if all of them are divisible by 16. 112 divided by 16? Sure enough. 112 divided by 16 is 7. So 16 times 7 gives me 112. How about 96 divided by 16? Oh, that's 6. 16 times 6 is 96, and 16 times 10 is 160. The other thing is, look at my powers of x. I've got x to the 8th, x to the 5th, x to the 3rd, so they all have at least an x to the 3rd. So let's pull out a 16 and an x to the 3rd. Right, when I do that, I'm left with a 7x to the 5th minus, well, we said 16 times 6 is 96, so I'm left with a 6x to, if I take 3 from 5, a 2. And then the last one will be plus 10, and that's it. What's left in there is not factorable. 7x to the 5th minus 6x squared plus 10 doesn't fit any of the techniques we've been doing. They're not perfect squares of any kind. I've got a 5th degree, a 2nd degree, and a constant. So it's not like a 4th degree, 2nd degree constant we can do. X squared, x to the 1st constant we can do. This, nope, we're stuck. So that's the answer. We do have to pull out that 16x to the 3rd, but then there's nothing else I can do. All right, look at number 12. 9x squared plus 64. You might look at that and go, oh, difference of squares, a 3x and a 8, but hold on a minute, it's not a difference of squares, it's a sum of squares. And you're not going to be able to find a number, actually two numbers that you can multiply to give 64 and add up to be 0, because they'd have to have opposite signs. You can't find two numbers with opposite signs that multiply to be a positive number. So we say that this one is prime. All right, let's look at two more, then we're done with this one. Let's take a look at 14. Those periods that are at the end of the problems are just like periods at the end of the sentence. Not quite sure why I put them there, but they're really not important to the problem. So let's take a look at 14. This one looks like a grouping one because I've got 4 terms, so I group. And you notice when I put that plus sign, I then include the negative with the 4x. So what terms do these have in common? They have an x squared in common. X to the 3rd divided by x squared is x. 7x squared divided by x squared is just 7, so in this case, minus 7. Look at the next one. I've got a 4x and a 28. Now notice the x and the 7 goes positive, negative. If I'm going to be able to factor this at all, it should end up also being positive, negative. So how do I turn that 4x into a positive? Pull out a negative 4. So negative 4x divided by negative 4 is just x. 28 divided by negative 4 is minus 7. So now I've got an x minus 7 and an x squared minus 4. Okay, so that's the first good step. Except now, that x squared minus 4 can still factor. So I'm going to keep my x minus 7, and now notice that x squared minus 4 is a difference of squares. So x minus 2, x plus 2. FOIL it back, you'll get back your x squared minus 4, so when I factor this, it's got 3 terms. And there they are. All right, last one, number 15. For number 15, this looks like another factor by grouping one because it's got 4 terms and nothing combines. So let's group these two together, put a plus sign, and then group those two together. So between a 3 and a 27, I can pull out a 3, and also notice I can pull out an x cubed. Divided 3x to the fifth by 3x cubed, and I get an x squared. Minus 27x cubed divided by 3x cubed is just 9. Let's pull out the negative and the 3. So negative 3x squared divided by negative 3 is x squared. 27 divided by negative 3 is negative 9. So I end up with an x squared minus 9 and a 3x cubed minus 3. Hey, that second term has a common factor of 3, so I can pull out a 3, and I'm left with x squared minus 9 and x cubed minus 1. And oh my goodness, now the fun begins. Look at that. They are both additionally factorable problems. So the first one, the x squared minus 9, is a difference of squares. So I can write that as x minus 3x plus 3. And then look at the second one. That second one, that's x to the third minus 1, that can be factored further also. Right? So this one over here is a difference of cubes. That's the one long term, short term. Not in that order, though. Cube root of x to the third is x. Cube root of 1 is 1. So I have an x and a 1. And then how's the pattern go? First term squared. Multiply x times 1, I get x. 1 squared is 1. So because it's minus, minus comes first, then the plus, always a plus at the end. All right, and the last thing to do is to remember that that 3 came with the problem, so carry that 3 down. This becomes a massive answer here. But now I'm at the point where I can't factor that anymore, right? Even that x squared plus x plus 1, it looks like maybe I can find factors of 1 that add up to 1, but I can't because 1 times 1 is 1, but 1 plus 1 is 2, and that's how the story ends. So there it is, completely factored. So once you do your initial factoring, always go back and check to see if it can be factored any further. If it can be factored any further, then continue factoring until all of the terms are what we call prime. And that's the end of the factoring part. The next section, we're actually going to take this factoring and use it to solve quadratic equations.